All right. Well, hi, hello, and welcome to Explore the Power of Edge with Red Hat and Forrester Research. Today's exciting webinar is sponsored by Red Hat with their special guests from Forrester Research and produced by Actual Tech Media. My name is Jess Steinbach. I'm with Actual Tech Media, and I am absolutely thrilled to be your moderator for this panel discussion today because I love when we get to dig into research like this. I love these reports, and we're going to explore these key takeaways and impacts. Together, we are going to be part of a discussion between top experts from Red Hat and from Forrester Research, and we will explore those important research trends, what we are seeing in the world of Edge. We're going to zoom in on what you need to know, those key action steps, the really important takeaways that will impact your day-to-day, and especially as you're crafting your Edge development strategy. We have so much to cover here today, lots to be excited about, and I want to get our expert presenters on out here with us and get things rolling as soon as possible. So I'm going to zip through a few important housekeeping points about our webinar, and then we'll get the show on the road. First, I want to draw your attention over to the questions section of your webinar console. Now, the absolute best part of a webinar like this, when we're exploring this sort of research together, is that you get the chance to ask questions directly of the incredible speakers that we have here with us today. And if we are unable to get to your question in our session, don't worry. The Red Hat team is going to be following up with all of you. So all of your questions, everything that's kind of burning a hole in your brain right now, make sure you get those questions in and you're going to get some answers back from Red Hat. Now, we can give this a little test run right now because if you haven't already done so, we want to hear from you. Say hi, say hello, shout it out on this beautiful day that you're, I'm sure, all having sunshine and rainbows wherever you are. We want to hear from you. So hi, Paul. Hi, Robert. Hi, Samuel, Richard, Reg. We've got Jorge. We've got a whole awesome crew here with us. Keep that coming in as we go through our day today. We definitely want to hear from all of you. You can also use that questions tab if you have any technical issues, knock on wood, of course, during our session. But I want to remind you that a browser refresh is probably going to knock out most of the usual tech gremlins. If they're really clinging on, you post a message in that questions tab, but try that browser refresh to start. All right, so let's move from the questions tab over to the handout section. It's right there next to each other. What you're looking for in the handout section are all the cool resources and takeaways, all the cool follow-ups to the conversation that we're going to have today. And there's a link there to get to know Red Hat a little bit better. Now, I know that you're all going to want to spend some time with Red Hat after we wrap up, so make sure you have clicked on that tab, open it. Don't leave us just yet because we've got lots of good info coming your way, but save that tab for after we wrap. All right, the last thing I'm going to tell you about is that I know you can see that little $250 icon on the corner of your screen there. That's our prize giveaway. So we have a $250 Amazon gift card as a prize drawing at the end of our webinar. Now, you do need to be here in live attendance in order to qualify to win this prize. And all winners must meet the Actual Tech Media prize terms and conditions. If you're not sure what those are, no problem. I do not expect you to have them memorized. That handouts tab that we were just chatting about, you're going to go back on over to the handouts tab, click into it, scroll all the way down to the bottom, and you will find the full T's and C's waiting for you there. All right, my friends, well, that was it for the housekeeping. We got through that nice and quick, which means it is time to get this webinar rolling. And I am so excited to introduce you all to this incredible panel of experts. Here with us today, we have Kelly S. Earl, Analyst Relations Manager at Red Hat, and Vince Tsugranes, Principal Chief Architect also at Red Hat, and their special guest, Devin Dickerson, Principal Analyst at Forrester Research. Talk about brain power, right? We're definitely going to have a great conversation today. Now, Kelly, I know you're going to kind of lead this conversation as we go through the discussion. I know you've got some agenda setting and introductions to do. So I'm going to step back and hand things on over to you. Take it away, Kelly.
Hello, everyone. I'd like to welcome you all to the Power of Edge webinar with Red Hat and guest analyst firm Forrester Research. Thank you for joining us today. Before we get started, there are a few housekeeping items that I'd like to share. If you experience any issues with the platform today, please type your question in the Q&A section, and one of our engineers will work with you directly to troubleshoot. Let's run through the agenda quickly. So, to begin, we'll have welcome remarks by yours truly, Kelly Earl. I'm Red Hat Analyst Relations Manager. Then we'll go through the insights on the 5 key trends that will shape your edge development strategy with our guest, Devin Dickerson. He's our featured Forrester analyst. Next, we'll have Red Hat's approach to Edge with Vince Tsugranes. He is the Red Hat Chief Architect, followed by a Q&A discussion with Red Hat and Forrester. Then we'll dive into customer adoption of Edge solutions by Red Hat's own Marty Wesley. He's the Red Hat Portfolio Architect. Next, we'll discuss next steps to consider when bringing Edge to your organization, and then we'll have an audience Q&A. Throughout our webinar, we invite you to use the Q&A function on your screen to ask questions to our presenters. We will answer questions throughout the webinar as well as at the end of the session. Our first presenter, Devin Dickerson, serves application development leaders and professionals. His research focuses on cloud-native development platforms, Edge, application modernization, and government application development strategies. He partners with development leaders and technology teams to create pragmatic tech delivery strategies, improve cloud maturity, and build high-performing teams across their technology organizations. Devin has a unique perspective from his U.S. federal government background, leading software engineering teams and government acquisition efforts to deliver applications in medical and defense use cases. Devin covers vital development markets, including cloud-native development, serverless and edge development, as well as all associate platforms, practices, and tools within those segments. Welcome, Devin.
Hi, thank you so much for the lovely introduction. I'm Devin Dickerson, Principal Analyst at Forrester. As mentioned, I cover cloud native and edge development. And today I'm going to speak to you about the key trends that our research has uncovered related to edge development and how this impacts enterprise modern application development and delivery strategies. So to start, building distributed applications is complicated. It forces developers and business stakeholders to make complex trade-offs between things like availability and consistency. And across almost every industry vertical, we are actually seeing an uptick in adoption of edge infrastructure and edge development platforms. And I think the headache of bringing new platforms into the stack is worth it. Bringing workloads closer to the end user can improve performance. Performing data analytics on site rather than centrally can deliver real-time insights, while also making it easier to comply with governance surrounding the movement of sensitive data. When we think about emerging use cases in things like AI and IoT, these platforms really abstract away many of the complexities of meeting the unique requirements of those areas. So I wanted to kind of dive in and give you a view of the modern application deployment environment. And so at Forrester, we have a view of the world that breaks the edge, the buzzword of the edge, into four distinct environments. Okay, so practically each type of edge computing serves different types of needs. So if we were to hone in on the enterprise edge is what helps enterprises and organizations extend beyond their core enterprise, beyond the core data center, beyond the public cloud. So this could be co-location data centers. It could be some kind of infrastructure provided by an enterprise infrastructure vendor. It could be a distributed public cloud type of deployment infrastructure. And it's really about offering interconnected infrastructure and software systems that connect back to core data centers and gateways. And these interconnected cloud computing solutions are there to offer these enterprises things like real-time automation, help with systems of employee engagement, and digital business data exchange. Enterprise edge environments don't necessarily need to run specialized applications for the businesses that use them. They tend to run the same type of software as the core, but it's just distributed in a more distributed, it's deployed in a more distributed context. If we look at the operations edge, this is where we start to think about automating processes at extended locations. So it's beyond the enterprise edge. Here, enterprises conduct business operations at places like distributed retail locations, industrial plants, logistics, and supply centers. These solutions, the edge solutions at these locations host software that is very specific to those local processes. This is where we start to see specialized edge use cases, things that probably couldn't be run in meeting all the requirements in a more centralized context. So we start to see things at these types of sites like lower powered networks, needing to run in disconnected or intermittent bandwidth scenarios, things like maybe using cellular broadband or SATCOM. We start to see things like IoT fabrics, industry-specific type of vendor solutions also live here. And what this is really all about for most users is helping businesses or organizations in the public sector serve localized and distributed customers. I had some personal experience doing this on the medical side, where we were actually enabling healthcare into forward deployed tactical sites. It could be war zones. It could be a place where ambulatory medicine needs to be deployed to deal with some kind of medical emergency. That is the types of use cases that we see in that edge. So when we get out to the engagement edge, this is actually where a lot of the growth in the market is. But it's not limited to just this. But when you think about the engagement edge, just think about systems of engagement. Think about web and mobile applications. When it comes to edge adoption, this is actually where a lot of the growth and opportunity has been. And the simple reason for that is just that every single company in the world needs some kind of web presence and often has some kind of mobile presence, where that is the primary means that their customers actually engage with that organization. So when you think engagement edge, think about distributed points of presence that put digital engagement capabilities, digital services closer to end users. And this, if you think about the types of use cases that are enabled, you can think about things like maybe a smart home application that can connect to a point of presence or an organization's data center that's in maybe closer than what a public cloud region might be. And you also could think about delivering more personalized e-commerce experiences or delivering really low latency use cases, things like buying concert tickets as soon as they go on sale, where you see that sudden spike in usage. That's what you see at the engagement edge. And then finally, the provider edge supports other edges. This is primarily the domain of telco and communications frameworks, content delivery, and SATCOM. So that's just an overview of the different deployment environments. When we talk about, when we use the buzzword edge, we're really talking about a set of discrete, different types of environments that need to be supported. Next slide, please. So at Forrester, one of the things that we do as part of our research is we put out a number of very well-crafted surveys. And one of the surveys that we have gauges reactions from enterprise developers, global enterprise developers in a variety of industries on some of their technology adoption patterns. And so one thing that has come out of both my evaluative research on edge platforms, edge development platforms, as well as our survey data, is that we're pretty bullish on the space. Enterprise adoption of edge technologies is actually growing pretty rapidly. And I think it's important also to point out that the point of these things is never industry buzzwords like the edge, even though I just took you through what we consider the 4 edges. The focus and reason behind what we see as these rising adoption numbers is because of what this type of technology can do for customers. Distributed compute and platforms that help developers and architects unlock distributed architecture for customers enables use cases that centralized public cloud alone simply can't cope with. And we think about things like personalized, performant web experiences, digital services. That's where a lot of the growth is. But there's also some really challenging use cases that enterprises need help with, things like distributed use cases in healthcare, manufacturing, retail, and these things are emerging. And there's a ton of fertile ground in the public sector, and in particular in defense, the world I come from, where distributed use cases with disconnected or limited bandwidth are extraordinarily common. These aren't uncommon use cases or specialized over in DoD. These are Main Street use cases that need to be supported even for business systems in many cases. And edge development platforms are really the key technology for product development professionals to take advantage of distributed compute, things like content delivery networks, and also an increasingly robust ecosystem of edge development services and technologies. Next slide, please. So I talked to you a little bit about adoption at the enterprise for edge infrastructure and in particular edge development platforms rising. But I think that it's important to dive in a little bit closer at what's driving adoption in the enterprise. So I'll take you through some of these, and much of this comes from a report that I did based on a number of interviews, data, and based on my findings from evaluative research, where I evaluated the capabilities of all the edge development platforms on the market, or most of the platforms on the market. So first thing I'll throw out there is that, and I alluded to this before, enterprises are leveraging edge development platforms to transform digital engagement. Digital engagement is still the #1 growth driver, even though new opportunities and new fertile ground is expanding use cases. But this piece is actually so widespread that some platforms in this market only focus on this. So if you look at something like, Vercel or Yext, this is all they do. This is web and digital, where you also have more general purpose platforms that can support the digital and mobile experiences, the web experiences, but also some general purpose use cases. But the reason that this is the main driver, like I said, is because all enterprises need some kind of web footprint and often some kind of mobile footprint. And edge development platforms probably offer the smoothest developer experience for delivering things like performant pages, especially when you're leveraging both static and dynamic assets at the edge. Things like improving SEO and delivering customer personalization to enhance e-commerce and business outcomes. Another thing, and this is where, if you recall one of the previous slides, I talked about the enterprise edge, and I think that this is probably the most important point in terms of looking forward in this market, is that the enterprise edge actually extends the benefits of hybrid and multi-cloud. And a little bit later, I'll zoom in on what drives enterprises to hybrid and multi-cloud a little bit more. But I think for now, it's just important to note that enterprise business and tech professionals, 65% of them actually cite that pursuing a hybrid or multi-cloud strategy is one of the highest priorities for their IT organization over the next 12 months. And we get that information from the Infrastructure Cloud Survey. And the top reasons that enterprise cloud decision makers end up adopting a hybrid cloud strategy or a multi-cloud strategy are things like compliance. They want more flexibility in leveraging services like best in breed. They want more resilience. So these are some of the top things. And if you think about it, incorporating edge and edge infrastructure and edge platforms into your thinking, into your architecture, into your strategy, it really gives you more tools to meet those concerns. Edge development platforms excel at hitting these notes, which is why enterprises continue to adopt them alongside flexible cloud native services. It's not an either or. And so the other piece of this are things like, we talked a little bit about compliance. We talked a little bit about resilience. If I were to zoom in on something like, say, the resilience concern, if you really bring edge into your thinking in terms of your design patterns, your development strategy, you really unlock a lot more flexibility in terms of thinking about something like resilience. You can build deployment models and follow deployment patterns that use things like replication across, instead of thinking about failovers between availability zones, you could be thinking about replication across hundreds or thousands of points of presence or within your, or some combination of that in your own data centers. And this is a powerful insurance policy against regional outages and DDoS attacks. And then we also see things like workload replication, smart placement. These things factor really heavily into application performance and user experience. And the really interesting thing is that using a platform to unlock this actually helps developers deliver capability with those benefits with much less complexity than doing it themselves. Because in addition to thinking about compliance concerns, when you're building a distributed application with partitioned data, you have to often think about these complex trade-offs between things like consistency versus availability. The platform can abstract a lot of that away and let developers focus on their code. Yeah, it's just a couple other things to touch on here. So another thing, public cloud costs often have the egress tax. There's often a cost optimization challenge. I tend to think a lot of cloud native patterns are a result of cost optimization, even if we don't think about it. And being able to put workloads closer to data sources and not having to move data around as much can reduce things like egress charges. And it's also very beneficial for data intensive use cases. And we're starting to see that a lot more with emerging tech, AI, and more mainstream IoT. And I think the last one that I'll mention is that platform capabilities over the last few years, because Forrester first looked at this space back in 2021 as far as evaluative research goes. And over the years, the platform capabilities have matured enough that some of the more conservative institutions, the governments, the financial institutions have really taken the leap. And so while edge computing initially thrived in the realm of R&D, prototyping, and experimentation, we're starting to see the enterprise-grade enhancements in areas such as observability, security, developer experience, service integrations, and interoperability with DevOps tooling. And this has eliminated a lot of the hangups that stopped enterprises from diving in. I'll keep it moving. I'll go to the next slide. So just to drill in a little bit more, not to belabor the point, but I think that this piece about hybrid and multi-cloud and organizations leaning more towards those types of patterns and those types of footprints is also driving edge development because many of the benefits overlap. So if we look at some of these numbers, we can actually see that these drivers actually match up with some of the benefits of edge that we just discussed. So if you need more clouds for compliance and regulation, for example, incorporating edge into your thinking provides much more granular flexibility in terms of where things run. Because in terms of compliance, a lot of this is about not putting all your eggs in one basket, or there being specialized industry-specific rules about where things run. Maybe it's a geography concern, maybe it's about sovereignty or a country. Instead of having to think about a region or even a sovereign cloud, perhaps going forward, we can start to think about leveraging all of these distributed points or having a more seamless path between the cloud platforms that we're taking advantage of and the enterprise edge locations that we have within our own footprint. That just gives you all the more flexibility to hit those compliance and regulation concerns. When it comes to flexibility and leveraging services, edge platforms provide yet another path of diversification. So if you want best in breed, bringing these types of platforms in, these types of technologies in, this is just another angle to be able to adopt the best of like services from a variety of providers. We talked about resilience. I think that there's a legitimate argument to be made that when you consider the out-of-the-box resilience from, say, a platform in the public cloud, in the centralized cloud, and then consider that against what you can do when you bring more distributed locations into the architecture. If you think about what that does for failover, if failover is not just failing over to a new data center in a whole nother region where that could massively impact performance where your data might not be located. And you compare that to maybe failing over to an endpoint in the next closest city. I just think that adds a lot of flexibility, and that could be very powerful for resilience conversations. And the last thing I'll say about this is that as edge platforms have gained more parity in terms of services with the public cloud, especially in data and stateful services, it has given a lot more opportunity for cost optimization, especially with regard to what I mentioned before with those egress charges. With more data intensive use cases on the rise, not having to move data around in order to be able to take advantage of that data. And if you think about AI use cases where data is gold, I think that is extraordinarily significant. Yeah, and performance and latency is really the main reason for living for edge infrastructure in many ways, and placing workloads not only closer to end users, but closer to data sources, as we've been discussing, can reduce latency and provide developers and architects with more flexibility to build out applications that can support those low latency requirements. Next slide, please. Right. So now we get into the key trends that I think will shape the edge development landscape going forward. We've already talked about why we're here now, why adoption is rising, why enterprises are leveraging this technology. But let's take a look at where things are headed. So there are really 5 key points that I want to discuss with you. One piece, and if you're not familiar with WASM, it's WebAssembly. I think WebAssembly is an important technology in the cloud native ecosystem, something that is not a replacement for things like containers and Kubernetes, but a complement. We've already seen WebAssembly prove its value in production within the browser, and now it's starting to gain traction in the backend server. I've seen some platforms are betting pretty big on WASM as the runtime. I don't necessarily think that this is something that's an either or between, containers, micro VMs, or WASM as the runtime. But I do think that as a portability mechanism, that it's something that enterprises should keep an eye on. And I think one of the things that it does too is that it opens up, it provides a pretty easy path for platform providers to support additional programming languages. So you're starting to see vendors supporting languages beyond JavaScript and Rust, which has really dominated some of the edge development platform space, actually. And you're also seeing new types of applications and use cases that can take advantage of WASM's really fast cold start times. So this is something that really brings a lot of alignment between maybe a serverless functions type of approach and edge computing. I think that this is a key proving ground to see whether WASM gains real traction outside of the browser. I mentioned this one before, but I think it's worth reiterating. Improved data services are opening up edge infrastructure to additional use cases. And don't get me wrong, there's a significant gap still between the breadth of services offered by, say, a hyperscale cloud provider and a very specialized edge development platform vendor. But that's why most edge platform customers leverage these capabilities alongside one another. And so I think one thing that enterprises might want to keep an eye on are platforms and control planes that really provide that cohesive experience across those environments. So if you're leveraging specialized edge infrastructure, specialized platforms that target one of the 4 edges, one or more of the 4 edges, and you're leveraging the public cloud, you've got your own data centers. I think that seeking providers that can provide a consistent deployment target, consistent experience across those different ecosystems is really powerful. Cloud native technologies are certainly not going away. How we comply with the cloud native patterns and 12-factor apps is going to be increasingly enhanced by artificial intelligence, but the underlying patterns remain the same. And I think that these technologies are things like Kubernetes, things like containers, things like functions and WASM. They're gaining traction, particularly at the enterprise and operations edges. And so consistency and control are often just as important as having a perfectly aligned tool. And so one of the benefits of leveraging cloud native approaches to development and deployment at the edge is that you get that consistency across your environments that we just discussed. So if I'm deploying something into a container platform and for my developer, it's no different than deploying it to the edge in terms of the runtime and the deployment model and the patterns. That just makes things easier. I'm writing once, I'm running anywhere. So another thing to keep a lookout for is workload placement. So one big challenge when it comes to delivering distributed applications is that the developer and the architect kind of needs to have a decent understanding of where things need to run in order to make the most of whatever you're targeting, be it lower latency or more resilience, cost optimization. You kind of have to do some analysis up front to figure out where an application or workload needs to run. If the platform can take on some of that complexity, especially at runtime, if the decision can be made based on the behavior of the application, based on the workload, based on what would deliver the most value in terms of performance or resilience, and actually place that workload when and where it's needed, that takes a lot of the burden off of the developer, but it also can greatly improve the customer experience. And as you start to open up your enterprise to a footprint in a distributed global context, this becomes even more useful. And so I would just keep a lookout for AI-infused intelligent services that help handle the very complex nature of choosing the best deployment patterns for your application. And finally here, edge platforms offer unique value for AI workloads. I think that this is actually really important. And while large language models aren't going to necessarily be consistently trained at the edge anytime soon, I think that you're already seeing lots of inferencing at the edge. And with the advent of smaller language models, I think that has the opportunity for being able to operate in a distributed context. And when we think about data is being generated all over the place. And having to move that data into a centralized location before we can take advantage of it with our AI applications is a considerable burden, both in terms of time, but also in cost. So if there are ways in which edge platforms can reduce that complexity, reduce the cost of taking advantage of all that data that's being generated by IoT or customer transactions or internal business systems, and also there's also overlap with things like DDoS protection, web application firewalls, rate limiting, and these also have some impacts with AI workloads, particularly in the chatbot space. Next slide, please. I'm not going to deep dive into this one, but I just wanted to just give a really quick overview about what's changed. Forrester looked at this market in terms of evaluative research twice, once in 2021 and once late last year. And we've gone over most of these, but I'll just say that there's a lot more parity in terms of service offerings between edge platforms and public cloud providers now. We talked about intelligent workload placement and how this is something that going forward could be a critical differentiator between platforms, especially as AI-infused operations, AI-infused development continues to develop. The market is still currently somewhat siloed into platforms that are more web-focused and built on top of content delivery networks. And then there are platforms that are more general purpose and are almost akin to like a hybrid cloud, multi-cloud platform that includes the edge. And then you see the more telco, ISP focused platforms that are just focused on delivering that last mile support. And the last thing that I would say has changed is edge is no longer the purview of hyper specialized use cases. We are seeing it hit that mainstream. And we're seeing it hit those enterprise end user use cases at long last. And to my final slide. And if there's one thought that I would really like to leave you with, is that it's the power of any platform that you use. A platform as a service is all about abstractions. And by building on top of any platform, whether it be one we build out ourselves or a turnkey managed service or anything in between, we take on the opinions and constraints of the platform, and in exchange, we reduce complexity. In the case of edge platforms, what we are getting in exchange are more performant, potentially more personalized applications And we're able to enable specialized use cases with IoT devices and industry verticals like healthcare, manufacturing, and retail. And there are still challenges. Edge lacks its own specialized type of Kubernetes that provides the common language across all environments, but things are advancing rapidly. One other thing that Edge doesn't have yet, but is once again advancing quickly, is it doesn't have the same depth of best practices or reference architectures that core cloud native has. And it's also lacking in standards. The shape is still shaping. But we at Forrester expect this to change, especially as platform providers are starting to place a greater emphasis on interoperability, and as the multi-cloud and hybrid cloud and application modernization story starts to become a part of advancements that are being made at the edge. So with that, I thank you and pass it back over to Red Hat.
Thank you so much. Thank you, Devin, for providing us with the key trends in modern app development. And now I'd like to introduce everyone to Vince Tsugranes. Vince is a chief architect in the CTO office at Red Hat, based in Durham, North Carolina. He has 25 years of progressive experience in software engineering, architecture, technology leadership, organizational design as well. He's a long-time designer and operator of event-driven and distributed high-availability systems. Vince works with a full spectrum of Red Hat customers across industries, advising on technology, process, and strategy. Welcome, Vince.
Thanks, Kelly. It's great to be here, and thank you, Devin, for that awesome presentation. I have a whole bunch of questions, and I'm looking forward to getting into the section where I can ask those, and we can talk about some of it in more depth. Like Kelly said, thanks everybody for joining. I'm chief architect here at Red Hat. I've spent decades in the transportation and healthcare sectors, so I've dealt with a lot of the globally distributed edge problems that come up these days. So I'm going to talk a bit about what Red Hat is doing to enable technologists to build edge solutions. We kept the audience size intentionally small today so we can get more interactive and specific to what you're looking for. So feel free to jump in with either high level or deep dive questions, and we can spend more time on areas that are of most interest to you. All right, so at the highest level, edge computing is about solving business problems in new ways, right? As computing power has increased, size and price have decreased, and we can add in high quality cellular networks to really do things that we couldn't do in the past. Right, there was a point where there were 5 computers in the world. Right now, most of us have 5 just in the room that you're in. Right, in the very near future, they're going to become an ambient feature of most of our lives. So, by moving more processing closer to data sources, we'll be able to solve new problems and make decisions faster. Right, scaling to the next order of magnitude in computing allows us, to solve new problems, but it also introduces new challenges. Right. For remote operations, for data volumes, for privacy, and even regulatory compliance. So Red Hat has been focused on the technology to address those challenges, and that's what I'm going to get into a bit. So first off, Linux, right? It's been a major driver of scale in computing for a long time. From the smallest embedded devices to the largest data centers, high-performance computing clusters, and public clouds. The modern world really does run on Linux. So Red Hat has been focused on enterprise Linux for a long time. It enables you to build infrastructure needed to run workloads at the edge. Right? This infrastructure includes operating systems as well as the supporting components required to update, maintain, secure, and customize those systems to efficiently run all the different types of workloads that Devin talked about, right? Traditional workloads, AI ML, cloud native applications, even virtualization. All right. So as we talk about edge, I think of some specific challenges, right? From resource limitations to reliability, remote management, and scale in the quantity of devices. So to baseline a little bit, this diagram actually very much mirrors what Devin had using slightly different language, right? So I want to go over what what we mean by edge at Red Hat, and just kind of where we fit in that picture. So we know the location of edge can vary by the business case. But here's a view of not only the different edge tiers that we often hear about from customers, but also a visual of Red Hat's focus areas. So we understand that computing is really distributed across all of these tiers, right? With the largest in the center and devices getting smaller towards the outside, right? That center is your traditional non-edge tier, right? From an enterprise perspective, this could be your primary or secondary data center. That provider edge is kind of any tier located between the core or regional data centers and the last mile, right? This aggregation level really isn't a concern for too many enterprise customers, but it is necessary at a certain scale and certainly important for telcos, ISPs, and clouds. That end user premise edge is really, I think, what most customers want to talk about, right? These are edge tiers on the user side of the last mile. This can include things at the enterprise edge, like a retail store, a factory, or a train, or the consumer edge, right? Like a residential household or a car. The device edge itself, right? These are usually standalone systems that directly connect to sensors or actuators via non-internet protocols. So one thing Devin brought up was consistency, and Red Hat has spent a lot of time thinking about consistency in management across all the systems in this spectrum. So we've worked to build this consistent platform from the data center to the cloud to the edge, right? Supporting the largest data center to the smallest edge device. So starting from the top, we've got Red Hat Device Edge, which is really our newest addition to this. This really extends our RHEL capabilities to edge devices, right? Starting with devices as small as 1 core and 2 gigs of RAM, as you can kind of see on the right-hand side. We also add a layer on here called Microshift on top, and then the second row down. And that's actually what gives you a Kubernetes API and container orchestration at the device level. We really do that with only adding 1 additional core of CPU capacity. So you'll probably hear a lot more about Microshift as far as enabling containerized workloads at the edge and using Kubernetes to give you consistency in terms of that management plane. Further down the stack, we're scaling up, right? I've seen stores where there are between 1 and 3 servers with 50 plus applications running on them. Now, what we've got listed here on the right side, right, are minimum system requirements, right? Your application sizing is in addition to what's listed here, right? So if your application is massive, right, and needs 256 gigs of memory, there's no amount of magic that's going to make it run on a piece of hardware that only has 2 gigabytes. So edge devices are important, not only in terms of managing your minimum system requirements, but figuring out what your applications need now and giving you room to grow those in the future. So Red Hat Device Edge bundles really all those things that you need for edge devices, right? Rock solid operating system with a pretty big ecosystem of supported hardware. Optionally, right, a lightweight version of Kubernetes called Microshift, and then management, right, to help meet and manage that at a scaled model. So there's some pretty interesting technology that's gone into Red Hat Device Edge that I want to talk a little bit about, and then we'll actually do a deep dive into. So RHEL for Edge includes capabilities to generate operating system images that are optimized for those edge workloads, as well as dealing with challenges that affect deployment for those workloads. Edge management provides services that secure, scale, and deploy those large fleets of devices, right? Trying to minimize infrastructure and the people costs associated with it. Device updates get optimized to reduce bandwidth, and those edge device updates are also intelligent by design, right? Ensuring that they're successful or rolled back. So we'll get into those in some more detail. All right. So here's an interesting one. This is called RHEL Image Mode, and this is actually something that we announced at Red Hat Summit just a couple of weeks ago. It's in tech preview now and combines the power of RHEL with the benefits of containers. So containers have really kind of become foundational for applications, right? Allow us to separate out the management of applications from the underlying OS. That separation continues to be powerful, and there's a huge amount of potential in bringing those two worlds together operationally. And this is exactly what we're doing with image mode for RHEL, right? It makes building, deploying, and managing OS images as simple as containers, right? So the same tooling that you use for your pipelines for containerized applications can now create full RHEL machine images and distribute them using only a container registry, right? So that also includes updates, right? So basically you come up with your new OS image, post it to your registry. When connected based on your settings, right, where all of your remote and edge systems can pull down that update and safely deploy it, right, rolling back in the event of any issue. So those updates are immutable, right? And the experience is very close to running a containerized application. So the major benefits to Edge come down to building, deploying, and updating those systems over time. We've got some articles in the works, so you're bound to hear more about that one pretty soon. Now, that doesn't replace everything we currently do in RHEL, right? Everything we do with RHEL is still called package mode. We have a lot of companies, right, with their tooling and build and deployment processes around that, and that's not going away. So everything there will continue to work. So let me get into a little bit of the technical details. So Red Hat Device Edge, the goal for us was to enable any type of application workload at the edge, right? From traditional package and process-based solutions using RPMs and systemd to virtual machines using KVM, containers using Podman, and then Kubernetes workloads using Microshift, which is really our streamlined Kubernetes and OpenShift for the edge. Right? So the base of all of this is RHEL, which we recommend using in that image-based mode that we just talked about. So some cool technical things that go into it, right? For operating system immutability, we use a technology called RPM OS tree, which is central to the deployment of edge devices. The concept here is to make the OS immutable while maintaining state in a couple of specific directories. Updates can then be atomic, right? Allowing us to implement rollbacks and staging of updates in the background. So those updates get staged in the background, right? They're applied transactionally at reboot, which can be scheduled. Transactional updates either means it all works or we revert everything to the previous state. There's no in-between half-applied updates, which is great for edge devices because it reduces the need to actually manage them on an individual level. This also works for major release upgrades, which can extend the life of hardware in the field. But you don't need to roll back, or you don't know you need to roll back unless you can detect a problem. And we do that with a feature called Green Boot. Green Boot, in essence, is similar to implementing unit tests for an operating system update. In other words, when you deploy an update, scripts can run to check that critical services are still running after the update is applied, right? If they don't, the update can be rolled back to the last known working version. This ensures that the edge device is always going to be in an operational state. So we ship all of these Green Boot scripts with the operating system, but it's pretty straightforward to write ones for your specific application, which is really important in terms of edge scenarios. Every application, you want to make sure when you do updates or when you roll out a full image, including a new application, right, that it's always working. We also do that automated rollback concept for containers with Podman, right? The auto update of your container will ensure you're always running the latest version of an image. If a container fails to run, Podman will detect that failure automatically and take you back to the last working version. If the development team updates a container, it can also be automatically pushed out. We also do efficient over-the-air updates, which is pretty straightforward, right? We basically just use deltas, which is a calculation of exactly the changed bits only, right? Even that gets compressed for transmission to edge devices. And of course, right, for all the devices and updates, you need some sort of central visibility. We help manage that full life cycle from dev to test to prod, and also allow progressive updates with canary rollouts, right, where you start small and confirm before updating the whole fleet of devices. We also support FIDO standards for automatic device registration and provisioning, which is actually really cool. So I haven't used this personally yet, but the first time I worked on an edge device deployment was more than 20 years ago, right? It was around 2002 when 3G networks became pretty broadly available, right? We had about 8,000 devices, and and they basically just got handed to help desk staff to manually provision around the clock, which took about, I think it was about 2 months at the time. And thankfully, that kind of stuff goes completely away with FIDO device enrollment. So it really helps in the field. The FIDO Alliance is a pretty good documentation on that standard. So if that's something that interests you, feel free to jump into it in some more detail. So that's kind of what I have for content. Now we really just want to make sure this is interactive. So next up, I think we've just got some discussion between Devin and me. All right, so we're up. So Devin, one interesting thing that you talked about, right, is resiliency, and you said you'd worked on things on the government side. I once met with a whole bunch of defense agencies, and I realized when I was talking to them that they've been around before any of their technology suppliers existed. They're going to be around long before all of those technology suppliers are gone, right? So their mission extends to, hundreds of years. How important is something like open source to a model like that?
Yeah, I think that's actually a really good question. And I'll start off by saying that I was working with teams on what I would learn later were edge use cases in federal government and defense before I even knew what edge was, before I'd ever even heard the term, because the need for these distributed applications that can meet mission critical use cases existed before the term edge, in my opinion. And the way that we used to do this back then was we were building bespoke middleware solutions, and we were trying to figure out how to get our stakeholders to kind of sign off on trade-offs between things like consistency and availability, the complexities of CAB theorem, but we need a business stakeholder who is in charge of, like, say, the medical program to try to understand what these trade-offs would mean to them and their customers. Because on the technical side, once you commit to these changes with a bespoke system, you're kind of in it for years. And the person that signed off on that trade-off might not even be there when you deliver, especially back in those days. So I think if we fast forward to today, and where things are moving more rapidly, there's more complexity that we can offload to platforms, but there's also a vast open source ecosystem that needs to be contended with. I think that it's really critical for the decision makers on the government side to understand all this, but it's also important to be able to understand how it actually applies to them with their unique regulations, unique requirements. And things like open source are easier to adopt in the federal government when they are packaged in a way that takes into consideration things like security, takes into consideration things like resilience, and takes into consideration things like ease of use and implementation. And sometimes pure download the open source distro off the internet doesn't check those boxes, but open source supported by a provider can.
Yeah, those are things we talk about a lot at Red Hat, right? We spend a lot of time figuring out what should be a default sane configuration, right? That it tends to avoid a lot of security issues in software just because of how you configure it out of the box, and especially using things like SE Linux and just having a platform, right, that's targeted for it can really help long term.
Yeah, unnecessary complex decisions, if they can be offloaded to the platform, and then the end user can focus on the things that are differentiating or critical or unique to their circumstances. I think that that's powerful in security, but also just in development in general.
Yeah, I like that you talked about kind of the operational benefits of consistency in a platform. That's something that we've been trying to push for a long time. But there are trade-offs with that, right? Sometimes it's, you're not doing something in maybe the best of breed way because you're doing it in a more commodified way, because the value of that consistency can be greater than like any individual benefit from a slightly optimized implementation.
Yeah, no, absolutely. I think that that's a conversation, and I'm sure this is the same for you. I have that conversation with my clients and customers on a near daily basis.
Yeah.
When there's kind of a spectrum here between maximum control and flexibility. And on that side, you download an open source distro and you engineer your own platform specifically to your specifications. But one thing that an organization needs to ask itself is how much of their needs are really unique, and how much is all of the work and pain of building and maintaining your own bespoke solution that's perfectly aligned to all of your requirements. How much is that really going to result in something differentiating and value driving? Because I tend to think that the best case scenario is that all of those commoditized requirements, all of those things that are common across almost every organization trying to implement a particular use case, and generally speaking, there's a significant amount of those. I might off the top of my head say that only 10 to 15% of any application these days is differentiating. And much of it is common or composed of third-party services. And yes, the way that you bring those things together is in some ways the power of modern invention. But that 80 to 85% that's commoditized, I say offload that to a provider that's aligned to your needs so that you can focus on that 15 to 20% that's actually differentiating. And I think that can carry most organizations pretty far.
So an interesting conversation I had with one of our customers at Red Hat Summit just a couple of weeks ago was around AI, because we talked a lot about AI. And we have a lot of customers right now, right, who are all in with a certain cloud vendor on AI, right? We're just going to do everything with this tool. And they started to realize, this is going to be an order of magnitude bigger than we expected. And we're going to need we're going to end up with multiple vendor solutions, because one isn't going to cut it for every scenario that we have, right? We're going to end up tying multiple services into every app, because composition becomes more important as we start to solve newer problems. So I do think we're kind of at an interesting time where people are starting to realize that composition means more than just one cloud provider, more than just one AI provider, right? That your destiny isn't just like all eggs in one basket.
Yeah, my experience with customers, being the cloud native development analyst, I do a lot of reviews of reference architectures and provide feedback. And one of the questions that comes up a lot with AI applications is about reusability. There's some fear that folks are building out and composing architectures that has some kind of AI solution in the middle of it, but a lot of common cloud native services on the edges of that. And what happens if you need to either take on capabilities from a new AI solution, or if you want to rip and replace someday? And I think that this is a legitimate concern. I think that extensibility and flexibility are more important than what many folks maybe thought initially when it comes to leveraging and making the most out of AI applications. Because at the end of the day, the infrastructure and the skill sets and the applications that are being built around these capabilities are expensive and need to be maintained. And there's always risk if there's no flexibility in terms of the core third-party services that you're relying on.
Yeah. So we made some other announcements at Summit just around open source solutions to exactly that sort of problem, right? So, right, you're not necessarily just beholden to a cloud provider service for AI, right? We have free models that you can tune and augment on-prem and know that they aren't going to change out from under you and for your critical applications. So I completely agree with you there. The other thing is you talked a little bit about, and I'm not sure where we are on time, but you talked a little bit about egress-free billing models, and that's kind of a key enabler to that sort of movement and not being financially restricted from application placement.
Yeah, in this. So there's the cost optimization piece, which we touched on during the presentation, and this has to do with when you cross certain boundaries with data sets, there's a tax, there's a charge, and if you can move business logic to compute that is closer to the data origin, to where maybe that data never needs to move into the egress and ingress zone. That can potentially lead to cost optimization. But there's also something to be said for the performance hit on that too. So I've seen one of the pitfalls a sort of anti-pattern with edge applications and edge deployments is that you get some of the business logic out to the edge, but there's some kind of dependency that's back in a centralized location. And you basically implement this dependency in the middle of your architecture that forces you to do a round trip to a centralized place like the public cloud, and then maybe back out to the edge to deliver a result. And you really lose a lot of the, not only are you getting an egress charge in that example that I just laid out, but you're also kind of eliminating the performance benefit of having deployed that application to the edge in the first place. And so I think that one thing that enterprise organizations need to think about is the architecture question. Like, how do we maximize the benefits of the infrastructure footprint that we've invested in and the platform footprint that we've invested in? And I think part of that is avoiding unnecessary round trips to the public cloud.
Yeah. And certainly, like, as we add more edge devices and the scale of it changes, the order of magnitude increase in the amount of data that people just have to sift through to get something usable on the back end because it hasn't been pre-filtered at the devices becomes a greater challenge too.
Absolutely. And user expectations are higher than ever before in that regard. So they'll notice the lag.
Yep, absolutely. Right. Not only the data volume, but the latency, especially in disconnected type scenarios where, you have a flood of data that coming through that's not useful when you have a connection, and you can't actually do the operations that need to happen.
Yeah, there are mission critical applications at the edge that need to be able to continue operating when connectivity is not available, and when it comes back, automatically resume its operations.
All right. Well, Devin, thanks for the discussion.
Absolutely.
All right. Well, thank you very much to that incredible team. Thank you to Kelly for leading us through that conversation. Thanks to Vince and Devin for those key takeaways and really important points. I know we went a bit long in our session today, but there was just so much to cover, and I really didn't want to cut them off. So we let Vince and Devin go with those final takeaways, which means we're going to move all of our Q&A to an email follow-up. So keep those questions rolling in. If you have any questions that you didn't write in already, get them in now. There's still time, and we're going to make sure that the wonderful folks from Red Hat are following up with you and getting answers back. So make sure you do get those questions in. Lots of great questions coming in already. So I know you guys are kind of brain lit up, which is a great way to wrap up an afternoon or a morning or an evening, wherever you're joining us from today. So hopefully you're geared up and ready to learn a little bit more, which also leads me to remind you about the handouts tab. Make sure you click on the handouts tab. Make sure you grab that Get to Know Red Hat a little bit more. Obviously, this is just the start, and there's so much more to dig into and so much more to explore with this research and with Edge. So make sure that you are clicking on that link, open that tab, and jump over there and spend some time getting to know Red Hat a little bit better. Now, we also do have a $250 Amazon gift card that's going to someone who is here live, present, and lucky at the webinar today. And that special somebody is Rachel Lieberforth of Illinois. Rachel Lieberforth of Illinois, congratulations. We will be in touch about claiming your $250 Amazon gift card after we wrap. Well, my friends, with that, on behalf of the Actual Tech Media team, I want to once again thank Red Hat and their guests from Forrester Research for making this absolutely wonderful webinar possible. A big thank you to our speakers here with us today. Some really wonderful expertise and insights and trends that we all got to explore together. Which, of course, brings me around to all of you, because my biggest high five, my biggest gold star, and my biggest thank you always goes to all of you for taking time out of your day and joining in this conversation. I hope that maybe you're leaving feeling a little bit excited, a little bit pumped up to learn more about how you can start to remove some of those limitations, create the differentiated offerings that you're looking for, maybe improve those operational outcomes, the speed, the efficiency, resiliency, all those really good things, all of that happening at the edge. So I hope that you're geared up, you're pumped up, you're ready to learn more, and I will say goodbye and leave it here for now, but I can't wait to see you all at a webinar again soon. Until then, have an absolutely beautiful end to your day.